Thomas, who has been a pillar of support in organizing this FDP. It's my honor to extend warm welcome to our participants from various institutions across the nation. Your presence enriches our learning experience and fosters collaboration. A heartfelt welcome to you all. As we proceed with today's session, I encourage everyone to engage actively and take full advantage of resource persons' expertise. May I now invite Dr. Ankit Saxena to begin with today's session on building and assessing measurement model in AMos. Over to you, sir. You are muted, sir.
Yeah, thank you, ma'am. So yesterday, itself, we had the basic coverage of the basics of, structural equation modeling, and we were also able to somehow demonstrate the basic applications of the AMOS. And in the beginning of the session itself, I've got a few queries to answer. So I'll be responding to those queries, and then we'll move on. So one of the queries from the Liji ma'am, I guess, she's saying that how do we move variables and data set to variables in the model? Though we did it yesterday also, but tomorrow also, today also, we'll be doing this exercise fresh, because we have a fresh data set. So we'll move on to that thing, and you can get your answer in that thing. Moderation variable, Geeta Savanya. So that is, will be covering tomorrow. Moderation and mediation will be covering tomorrow. Today, as I shared yesterday only, that today I want to cover the basic path analysis, and then we'll talk about the confirmatory factor analysis. If time permits, and if we are able to stretch to somehow, to the discriminant and convergent validity, I would like to cover that topic as well. So that is the agenda of the day. Let's see how does it go. So that's how we'll be moving on. And tomorrow we'll be taking up your query regarding that moderation and mediation analysis. With direct and indirect effect, we'll cover everything over there. Right. So Abhi, right now, let us move on to the yesterday's file only that we were. Yes.
Sir, kindly tell what is the difference between confirmatory factor analysis and path analysis, and why we do path analysis.
Okay, now. See, confirmatory factor analysis, as I explained a bit, yesterday. Today we'll be going in deep of that thing, and because both of the things will be doing today only, so you'll be understanding the basic implication of both. So in short, to answer that query, the path analysis is basically somewhere you have certain observed or latent variables in your data, and you want to develop a model. Let's say A is leading to B, and B is leading to C, and then there's another variable D which is also leading to B, and then some other set of variable interacting with each other. So when you have such set of data which are interacting with each other, you want to develop a model and try to see that relationship, so that is significant or not, whether that model makes some sense or not. So for that purpose, we conduct the path analysis. We'll be doing that practically, so you'll understand what we are saying. And confirmatory factor analysis is a very different technique. It's not related to path analysis. And some of the time, the basic mistake that people commit, they obviously confuse between these two techniques over the in confusion, which is not right. So confirmatory factor analysis, as I explained yesterday, the concept of EFA. So in EFA, what happens? We normally go with that set of questions. We want to know that which set of question is actually, can be clubbed into, one category. That is what we call factor or construct. And that is where the exploration is, done. So we want to explore that which variables fit in which factor. So we have asked, I gave you example, we have asked 20 questions. So if question number 1, 5, 11, I guess I said the same sequence. So 1, 5, 11 fits into one factor because the responses, that we are getting on these questions are very similar. So they align to each other. So that is where we can say, okay, this particular, factor, these three questions fit in this factor. We may have four other questions, let's say question number 2, 13, 18, and 20, and they are having similar responses. So people are thinking alike on these variables. So there might be something in common over there. So that is what we do in the EFA. Now the CFA, confirmatory factor analysis, is slightly different from what we have discussed right now. So confirmatory is like we are adopting a scale from somewhere. We are, sometime what we do, we adopt a scale, then we modify, few items in the scale. And we would just want to make sure that whatever, uh, items or the variables or the questions we are asking in one particular construct, are they aligning to that particular construct truly or not? So confirmatory factor analysis, you have already, a set of variable which are leading to one construct. You just want to confirm whether these constructs are well defined, by the selected set of, questions that you are asking. In analysis, we call them item or variable. So question, item, variable, they go, synonymously there. So whatever questions we are asking to measure one particular construct, whether that is being done clearly, that is what we do in the confirmatory factor analysis. Right. So just before moving to the factor analysis, let us complete the exercise that we were doing yesterday, and then we'll move on to the thing. So very first thing that I did yesterday, we just changed the interface properties here. So I'm using Control I. I normally use that shortcut because I use it very often. So Control I. Those who missed yesterday's session, they can recall that we can actually do it from here, view and interface properties. The shortcut is also mentioned here, which is Control plus I. And it is not a mandatory step, but it is just, it provides me wider canvas to draw my model, which makes my work easier. That's why I prefer to work it on landscape, and you can choose any paper format over here. I'm using landscape legal. So what it does, it basically gives you the entire screen to draw, so which is like handy. If you don't do it, if you just put it in the portrait mode, you have a lesser canvas to, work with. So that is one thing that we do. So once it is done, we have to do, now we are doing step by step. Yesterday it was, things were slightly, because I just wanted to explain few things basically. So I went in that zone. So let us now retrieve the data in this particular, AMOS. As someone asked me on the very last few minutes of the session, and that was a relevant query. When I worked on the AMOS on day one, way back, so I was like, okay, where do we have data here? Where to enter data? Because normally, any analysis software you open and download, and you normally look to enter data there. So one thing we need to understand, that this software has nothing to do with the data entry. So this software is only meant for analysis. And this is technically a kind of cover software. So it is, linking, it is integrating with other version of the data that you have already entered. So most commonly, what we do, we normally either have data in the SPSS file, we might have entered data there, or we might be having data in the Excel format, or even in the Notepad or MS Access or any database format you can have. So this will be, connecting to that file. So there's no data entry possible. So we will be having a separate file for that purpose. So that is one thing. So that we discussed yesterday. The few things that we have already discussed, but just to remind you, and sort of, next 2 minutes, you'll be recapturing what we did in the last few minutes of the yesterday's FDP session. So very first thing we do, we normally start with selecting a data set. The very first step is you open the AMOS, then you, if you wish to change the, just a minute, I have to take this call, just a minute. So that way, we just, if you wish to change the landscape, you can do that interface thing. And then you first of all get the data file. So let me just do that. So there are three ways of doing that. First way is you can click directly here. The second way is you can use the shortcut key Control plus D, D for data. And then otherwise, if you're not able to recall all this, you can directly go to the file, and then you can click on the select data file. So I'm doing this way. Either way, you'll reach to this dialog box. And then you have to specify the file name. And it will ask you where you want to search for the data. So I have my data in the downloads folder. So right now I'm working on the data that I shared yesterday. That was multiple regression demo. In the next few minutes, we'll talk about the confirmatory part. So this is the multiple regression demo. And because this is basic, I want to cover that, and then we'll move to the path analysis, and then we'll talk about the confirmatory factor thing. So that's what you click here, and this will be integrated. Right now, I'm using a laptop of my friend. So in this, I don't have even SPSS installed. I just quickly, get AMos installed in the system. So we don't have even the SPSS in this system, but still that will be able to somehow, work that way. So it's not that important to have SPSS installed in the system. So if your file is in any format, you can attach it to the software. So I just quickly click it OK here. Nothing will happen. You won't see anything happening and coming up here. No data file will be visible to you. There was an option to view data in that, recently closed dialog box. Now, what is the change? You can click here. Just a minute. Yeah. So in this case, if you click here now, you will be seeing this, variables. That list is there. So this was the file that we were working yesterday only. So these are the variables in the data set. So these variables we do have in the data set. So this is the variables in the data set. And if you click here, this is the variables in the model that you are drawing. So variables in the model. So this is what we are picking from this third row. So third row, the second column allows you to see the list variables in the model, which you have drawn. And this is the original data set that you have actually, uh, connected with this particular AMOS. So this is the graphical user interface. So if you wish to enter a title here, so you can click on the title. We did that yesterday only. So you can just click on the title part here. And so whatever we are doing, it is simple, multiple, let's call it multiple, way too complicated. So multiple regression. So we are running on the multiple regression, and whatever bold, italic you want to do, you can do all that thing here. You can increase the font size and other things. You don't have much formatting feature. Obviously, it is not meant for that purpose. So you have that title coming at the top over here. So now what we are going to do, we'll draw a model and try to run it. Yesterday, we didn't run anything. So someone asked me for running the model. I didn't do that. So today we'll be doing that. So that is what we are going to do. And then I'll explain you some of these things, the standardized estimates, and what do you mean by unstandardized estimates? How do you read the output of these, AMOS? And AMOS is wonderful software in terms of in the, interpretation of output. It does majority of things on its own.
Sir,
Yes.
so sorry to disturb, sir. So can you please tell me how to change that page settings, sir? Because it is not moving for us, and it is coming in portrait only. Landscape we are not getting it, sir. And also regression model, like the data what you have sent in that, we need to be do anything, sir.
No, we don't need to do anything. So if you're not able to change the interface, you just go back on the system and click on the view and click on the interface properties here. If you can see this box on your system, this should pop up.
Yes, sir.
And
It's
if
coming.
it's coming, then click. Obviously, by default, it will be on the page layout. I'm not going in further things over here. That's not much needed. You can have colors and everything like that. That you can do things. So I'm not doing that artistic thing. So you just come to paper sizes here, and by default it is on the portrait A4. The moment you open it, it is by default in portrait A4. You just go down and select it to any landscape that fits your screen. So I'm using landscape legal.
Okay, thank you, sir.
And the moment you will just click here and you just need to close it. Nothing to apply. The moment you'll close it, it will change automatically like that.
How to import data files, sir? Can you repeat in a minute?
Yeah, sure. So for that, you will be either clicking here on this select data file. You can use Control D, or you can directly go to the file, and data file option is here. Either way, you'll be getting to this option, data files. Then you will click on the file name, And in file name, you should know where your data is there. Mostly, if you have downloaded, it must be in the download folder. Wherever that data set is there in your system, navigate to that place and then click on that file that you want to import to the AMOS right now. So we are working on that multiple regression demo. I have not changed anything in that file. So
Thank
just
you.
click here and open, and
Okay.
that will open the file. The moment you'll be opening this now, the difference you'll see, uh, if you have not attached any data file, you'll not see any variables in the data set. But right now, when I click here in the variables in the data set, I see all the variables which are there in that data set. This is the advantage. Now I can perform any model, any analysis on these selected variables in that data set. Okay.
Sir, good morning.
Good
Sir, I
morning.
want to know, like, what is the commercial application of this AMOS? Commercial application, is it audible for you?
See, my intent to be here is the academic applications only. So I maybe not, I may not be the right person of talking about commercial application because I have not even done it and thought of it. Normally it is used for, conducting researches, somehow, validating certain theories. Uh, if some companies like maybe they are developing a model and they want to, copyright it and patent it, maybe that way it may be a commercial application. But as of now, what I believe, like we all are here for the academic applications of the model. So I'll be restricting and reserving my opinion to that.
Session was very informative. Just I like, since I am from a commerce background, that's why I asked you.
You are
I,
okay. You're talking from the subject perspective. Okay, I took it. You said commercial perspective, so I just thought you were thinking in that commercialization thing. Okay,
so,
commerce. You're talking about subject, right? See, what you need to understand, ma'am, that we have certain problems. Let it be management. I'm a commerce graduate, so I can totally empathize with you. And most of the time, commerce graduates think that way, that these things, are not meant for us because we'll be working on time series data, something like macroeconomic variable data, some stock market data. But at times we do conduct surveys, like, so we may be conducting, a survey where we are conducting a survey like, okay, we have launched this thing, we have introduced this particular, government is spending too much on the, startup India and other things. How is it leading to the employability of the nation? So if I have data of that nature also now, that can be also applied in these kind of researches. Ultimately, it's up to you. Right now, what examples I'll be taking, let me be honest with you that these demo files are, I've also downloaded from somewhere. It is like, you search on the Google data sets for this analysis, you'll get it. No one creates their own data sets and no one will share. I have worked on the AMOS in my research paper. I won't share that database with you because I'm still exploring some other, publication potential from that. So these are already publicly, available data sets. So please don't get that way confused that it cannot be applied in commerce. It can be applied in commerce. You must think, okay, I'll be developing a model where the multiple, macroeconomic variables are interacting with each other and they're leading to certain variable, let's say GDP or inflation or capital market performance or something like that, whatever your area is, right? So that way, there's an interaction in all the macroeconomic variables. So we can, right now, what we are saying performance goal. We can make it, GDP achievement. We can make it, per capita income, mastery. We can make it some other variable. So the variable's name will change. So please pardon me for that example that I'm taking, but everything is connected with any set of stream. You can apply it any domain. You have to just visualize, what problem I can pick up and what models will be there, what variables will be there, what interactions will be there. How can I put it in, a model, and you'll be able to apply it. It is very much applicable in the domain of commerce. I just took it your question. Otherwise, I thought commercial. I just
sir, I feel it is very much useful for research purpose, especially in the field of commerce and management.
yes, yes, yes. It is. It is. Mostly, we people are using it. Social sciences is the broad area. Don't reserve yourself to the commerce. So social sciences is the broad area. We are, talking a lot many things in the social sciences domain. So that is all, we are interacting. And nowadays, what has happened? the research papers which are having multidisciplinary approach, they are well taken. So it is better to go with something which is multidisciplinary in nature. So that will be a good idea. So I think that serves your query.
Sir, good morning, sir. Sorry to disturb you.
Yes.
Just 1 second, sir. Sir, you told that files can be imported from AMos, and you can primarily enter any data using any keyboard. But what are the different types of file extensions that can be used in AMos, sir? Is it only .sav or even any other file extensions?
So that way you can see what are the extensions possible here. So you can just quickly see here, these are the extensions which are possible. So we can export data from Excel, FoxPro, Lotus, Access, text, and all these data sets are available. So I believe most of us work in either in XPSS or Excel. They are there. So that serves my work, right? So let us move on.
Thank you.
Otherwise, we have a limited time allotted to the session, and someone has pointed out this thing very rightly. So let me just move on, because otherwise we'll not be able to complete the target. These interactions are very, very useful, but let us move on with the other things now. So what we were doing yesterday, we were drawing certain variables. So let me tell you that this set, in this question, in this data set, we have the values of constructs here. These, these measures, these are the measured values which are there. So we have the measured things. So like this can be any problem of commerce, as I told you. You could have taken the data of inflation, GDP, some monetary policy rates and inflation rates and other things, and you could put that in the model. And please understand one thing before moving further. Whenever you are developing a model, do not put your innovation and imagination in that model. It has to be validated. Any relation, any error, it's not fun. You are making a model, so you cannot say that X leads to Y. There has to be a support for saying that. So you must, because if you say that X leads to Y and it is a vague random idea that just pop up in your mind from nowhere, so it will not be well taken in the academic fraternity. So you must support that so and so author in his paper, in his analysis, has established this relationship that it this variable X leads to Y, then it makes sense. So any model will not do well. Right now what I'm doing, just as a demo, I want to make you learn this software. That's why I'm just putting, and let me be honest, I don't even hail from HR. So these topics are from the HR. So for me, all HR terms are like similar things. So for me, performance and anxiety, achievement, mastery, interest, they are all same. So I'm not doing that theoretical justification in the model. So please pardon me for that thing. So let us quickly draw a model. So I'm just drawing a observed variable. This is a observed variable that we have just discussed yesterday. Let us copy few. So I'm just copying three variables here, and let us make sure that it is leading to one particular variable here. So I'll just drag some things here. Let's say performance goal here, that comes here. Achievement, let us put achievement and so this is drawn wrongly, so I'll just remove it. You can just quickly go back here. Achievement, let's say, is the dependent variable. It sounds more like a dependent variable. Mastery, the someone who is master maybe achieve more. The someone who is interested may achieve more. So let's say we are putting this model like this. So what we have done, you can see what we were doing. We were dragging variables in the data set, and now we can see these four variables are in our model also. Let us quickly draw some relations here. I'm just randomly drawing these arrows, not worrying about their symmetry, because for that we have touch up button. We'll use it later, and we have done it. I want to also correlate all the independent variables. So I feel like someone who is master, will be more driven to performance goals. Someone who has interest will have more mastery, and maybe someone who is interested, will have more performance goals. So I have done that thing. So this is one thing. Then you can just quickly go to the touch up if you want to just beautify it in quick go. So this looks better now. So this is how we have developed one particular model. Now let me just do one thing. I want to add some error term to my dependent variable, because this might be some error which is not explained by the selected variables. So there might be some disturbance in the model. So I want to capture that as well. So this is for that unique variable we are adding to an existing variable. So I just click here and I'll come and click here. So the moment you reach to one particular box, you see that becomes red. Even if you move on to the you can add only to some observed variable like this. So you click here and this will be done. If you want to name it, then you have to just click here, click back to this circle here, double click here, and it will ask you to give you one name. So I'm just giving it E1. You can assign that name D1, disturbance, a term, or other term, anything you can mention. Name is not important. Now, what you will observe closely, if you see that this has by default taken a regression weight of 1. So if you click on this arrow and go to the parameters, this has taken the regression weight 1. By default, AMOS does that. Do not play with it. If you will make it 0 or you will change it, the model will not run. So we have to assign one value. System by default does that. So there's no fun entering that thing. Now you see we have got another variable in our model, that is error1. So let me just now go to the analysis that I want to do. So I'll click on the analysis properties. And by default, I'm selecting maximum likelihood model. This is the mostly used model. We have limited time. I can't explain all these models to you. Some other day, some other way we'll connect probably, and then we'll discuss those things. Let me just develop the basic thing. If you're working on the maximum likelihood, it is good enough to move on. This I explained to you yesterday also. If you have something in your data, that is missing data, so then you can check here. You have to check here. You can click on the estimate means and intercepts over here. What happens sometimes we don't do that, and if we'll run the model will identify that this data has certain missing values, and then it will pop up. It will give you an error message that your data has certain missing values and you cannot run the model. Then you need to do it. So sometimes, just to avoid that potential error, we normally click here. That even if some data is missing, it will estimate that thing, and intercepts will be estimated and the analysis will be executed. So even if you have nothing as missing data, you may as a precaution do it. But I hope when you are entering your data, you know whether your data has certain missing values or not. So if your data has all the values, do not check. But if you're not sure, then you can check. But ideally, it should be checked when the data has certain missing values. That's the thumb line. Now come to output part here. Because we are running a simple multiple regression, so more, other things are not of that relevance here. We want standardized estimates and we want squared multiple correlation. This is known as coefficient of determination. So I'll explain you that term in a while. So we have clicked on these three basic things over here. So we can check for the normality also. We can check for the outliers here. So today we are not doing that. We are keeping this only 3 points we are considering here. So let us close it. Nothing has to be saved or something. Once you click here, it is by default saved. So once you have checked on any item, unless and until you change it, it will be there. Now you will come to this calculate estimate, but before that, because we have not saved the model anywhere, so we need to save this model. Otherwise, the analysis will not run. So I'll just quickly save it. Control S will work as always. So you can save it somewhere. So I'm just going on the desktop, and in desktop, I'm just clicking on day 2. Day 2, let's say multiple regression. So you can assign any name to that particular folder, and then you click here and you just gives one name to that file. So this is MR demo. So I'm just clicking MR demo. So you can click here and save it. Somewhere you have to save that file. Once the file is saved, you can run the analysis here. So you can quickly run the analysis, calculate estimates. The moment you'll do, you'll see some, screen movement and few things. And then you will see this message here that minimum was achieved and writing output and all those things. So the model has run the thing here. So now how do we get the output here? Where do we have the output? Analysis has been done. So how do we see that analysis output here? So let me just quickly see. You have this top box here. So what you can do, you can click on the view the input path diagram. You can click here. So this is the input path diagram. When you click on the right hand side, which is the output path diagram, so you'll click here. And you'll see, many values are over there. So that way you'll see most of the values are there. So what they are actually, just give me a yes. So what you see here, there are two types of estimates. One is the unstandardized estimates, and then we have the standardized estimates. Now, what is the difference between these two? We need to understand. Unstandardized estimates, take the values in absolute terms. So let's say we are taking sometimes, as we were giving example of commerce. So in commerce, the rates, if you talk about inflation rate, it will be near about 10%, right? If you talk about uh, any other rate, which might be, let's say you're talking about some inflation, let's say some kind of other index which is in the range of 100 plus, that will be there. If you're talking about GDP, it may be in crores. So what happens, the three values are which we are using, they are very different in scale. So the unstandardized estimates, Abha is asking, can you repeat how you got these values between variables? I'll do that. So let me just complete what I was saying, then I'll be telling you that thing. So what we did here is that, so when we are talking about unstandardized estimates, they'll be taking the values in their exact sense. They don't standardize those things. So if one value is 10, the other value is 100, the other value is in lakhs, it will be not standardizing that estimation. But when you talk about the standardized estimates, they normally adjust all these values to one particular thing. So that way, the like correlation, correlation is a kind of a standardized estimation, because here, we don't see anything like if you're moving in 100 or if you're moving in 1,000, ultimately correlation will be, that way. But if you talk about covariance, if you talk about variance, these are unstandardized estimates. So as of now, what we are seeing the correlations over here. So the question came that how we got these values here. So I'm just clicking here. What I did, once we saved the file somewhere in the system, we just saved this file using Control S. That was step number 1. Before that, we had specified that we wanted to achieve these three values that we specified, and the step number 3 was to click on this calculate estimates. The moment we did that, this happened, and the moment you click here, view the output path diagram, you'll see the values over here. So by default, what you will see, how did you insert E1? For inserting E1, we just clicked here. So right now we have already inserted. So for example, if you want to add to this particular, let me just, we go to input diagram. So you click here. For inserting an error term, you can click on this second line, third option, and then you click here, and then you can insert that error term to any observed variable. So that's how we did that, and you just need to name it once. You have to name it. So let us see. These are the outputs that we are seeing. Let us see the output in some other way also. So if you will click on this part, view text. So this will tell you the output part. You can also see the output looking from the view. So that is there. And if you know the shortcut key, that is F10. You can click on the F10 to see the output also here. Thank you for confirming. Right. So if I just quickly click on the output part directly from here, I know this is the option. So I'll just click here, and I'll be able to maximize this thing. Let me just quickly show you a few things over here. We see the estimate.
सर पाथ एनालिसिस में डिपेंडेंट वेरिएबल ओवल शेप में क्यों नहीं होता, रेक्टेंगल शेप में क्यों होता है, और कन्फर्म, और जब हम सम यूज कर रहे होते हैं तब वो ओवल शेप में होता है, व्हाई?
See, dependent variable may be in some time oval shape also, but normally the path analysis is normally used for the constructs which are observed in nature. So that is the point here also. What data we have, all the values are observed in nature. That's why we are putting them in rectangle. I'll be giving you that explanation to you, maybe tomorrow's session when we'll be talking about mediation and moderation thing. So I'll be explaining you that thing, that, how can we make some models with the latent variables. So that we will do in tomorrow's session, because then we'll be interacting with the latent and observed variable both. So that will be covered in tomorrow's session. So as of now, what we are dealing with, they are all observed variable in nature. So they all are observed in nature. They're already there, right? So let me just quickly show you the output that I was explaining you. So let me just come to the output part, and I've seen that. So these are the estimates that you'll get the important information here. So if you see that, okay, I've said that performance goal leads to achievement, mastery leads to achievement, interest leads to achievement. And what you see here, these values are there, right? And the good thing you see, the moment you scroll on any number in the output, this is not, I'm rarely seen this feature in any output mechanism. You don't know, statistics wise, we are not that acquainted, let's say. Fortunately, I was taught by one great professor, I value him like anything. And because of him, my interest in statistics was way too high. And, some people wonder that how can I be so good in statistics being a pure man of finance? But because of him, probably my interest is still there. And I keep on learning these things. So that, and sometimes, these things like, I don't know what this standard error is all about. So I don't know what this is telling me. So I can just click here and the AMOS will, give me, that answer that what it is. It is not giving you that explanation further, but if you click here on p-value, so this tells you exact interpretation also. So what it is telling you that sometime like we say that performance goal is leading to achievement. And if you understand the basic hypothesis, so hypothesis is like what? Your null hypothesis will be that there is no significant dependency of achievement on performance goal. That performance goal is not leading to achievement. That's what we make a null hypothesis. But here the p-value is less than 0.05. It is less than 0.05. Here your null hypothesis is rejected. I hope we are all aware with this thing. Otherwise, I can take 1 minute though. We normally make null hypothesis assuming that whatever we are studying is not existing. So we say there's no significant dependency of the dependent variable on independent variable. Dependent variable here is achievement, which is depending on performance goal in the first line. So now if I say there is no dependency of achievement on performance goal, this is my H naught. Now, how do I accept or reject? For that, I have a thumb rule. If my p-value is less than 0.05, then I reject my null hypothesis. I'll be happy that, okay, there is some significance dependency. So performance goal actually is, one significant predictor for achievement. So the achievement is depending on performance goal, clarity or whatever that term is. So that way, this is significant. If you're not able to make it out, you can read it here. So what they're saying, this value is 0.032. In other words, the weight is significantly different from zero. It is not zero. That means it is significantly different from zero. It is significant. So that kind of things are there. Even if you want to see the assumptions, it will open up that assumption part as well. So some kind of basic thing, it tells you what is critical ratio, what is p-value. So it tells you the entire thing, how they are calculating it, how they are getting this number. So all that things are there. So this is a good thing. If you have certain basic understanding of statistics, it helps you like anything. That is one part. So in general, if I quickly tell you, when you see these three dots, these values are less than 0.001. So they are also significant. You can click here and you'll find that it is less than 0.001. So the number that are very less, 0.000 kind of numbers, they are shown like this. So this is also leading. So all three, values are actually leading to this particular thing. So when you see 0.009, 0.340, 0.199, so just go back to the thing. These are the unstandardized weights. So let me just change to the unstandardized estimates here. So these are the 0.01, 0.009, this 0.01, 0.34, you can see 0.34, 0.199, this is 0.20, what they are writing. So these are unstandardized regression weights that are shown on this particular, lines. So these are factor loadings that we also call. These are the unstandardized regression coefficients weights that we are seeing on the diagram. Now, if you see the regression weights which are standardized, because sometimes the values are coming from different scale, so we have to standardize the concepts. So in that way, we get these numbers. So if you just convert to standardized estimates, you'll see 0.14. You can see 0.14, 0.373. That becomes 0.37, 0.28. This is 0.278, which becomes 0.28 over there. So this is the basic thing that we are getting over there. Now, yes, ma'am.
Sorry to disturb you. Again, I think yesterday I asked you the question, whatever the beta value we get after running the model, how can we define that these are the standard value for this one? Is there any document available, or again we have to go ahead with the basic stats and understand the things?
Basic statistics there will be required. You asked about the model fitness indices that I'll be sharing tomorrow, because we'll be talking about fitness indices.
Yes, yes, sir.
That I'll share in the group that I said today. I'll share.
Because here, if we check that pref goal to achieve, the value is minus 0.14. Then mastery to achieve, it is 0.37.
370.
Then how can we define it that these are the values and what are these?
See, the regression equation normally that we get in SPSS or in any other software, we get only these regression rates. So the unstandardized estimates we normally get in any software, whether you use R, Python, SPSS, or any other analytical software, even Excel. For that purpose, you will get these regression coefficients. So regression equation, normally, has these beta values over there. But I hope you understood the method and implication of the standardization of the
Yes.
regression rates.
Yes, sir.
So if you have three, x1, x2, x3, which are coming from different scale, so then
Yes.
it is very important to standardize them to make some forecasting. Otherwise, that values coming from different scale will be very difficult to put all together one and same equation. That is where we standardize the regression rates. So we normally don't
Okay.
reach to that level, but in general, we publish whatever we write in our research papers, and you see in even good journal papers, they normally go with the unstandardized regression rates because most of the
Yes, yes.
softwares provide that only.
Actually, I am also struggling with the same. That's why I joined this session to understand what will be the values exactly, and how can we go ahead while writing the interpretation.
See, for that purpose now, see, these are some specific queries. One query has been coming about the moderation. Moderation I wanted to cover, but this is a specific
Yes.
query. For that, I'll drop you my email ID, and we can
Okay.
connect on that, interaction part,
Yes,
and
sir.
we will definitely solve your query.
Thank you, sir.
Okay. So that way we got these numbers, and when you see that covariances are there, correlations are there. So these covariances, minus 6.254. Let me go back to the chart that we got here. When we click on the unstandardized estimates here, so you see minus 6.25, and this is here in the output, you see minus 6.25, 1.49, 7.15. So you will see these are the covariances numbers, 7.15, 1.5. So these unstandardized things will show you the covariances. But the moment you see unstandardized, why we are calling them unstandardized? Covariances, these variables are still having something within a range.
Sir,
Yeah.
sorry to disturb you, sir.
Yes, ma'am.
Sir, how to change this screen, sir? That
How?
result, how to change the screen? You are just changing this screen
How
to that
I'm changing that?
result. Yes, sir.
I'm clicking on these things. I'm clicking on unstandardized estimates here, and then clicking on the standardized estimates.
No, sir. Not this screen. From this screen to you are moving
Acha,
towards
the
Sir, output.
estimate. So,
Output.
yeah, output
I'm just
base.
clicking on Alt tab here. I'm just clicking Alt
Alt?
tab here. Alt plus tab.
Alt plus tab. Okay, sir.
Yeah.
Otherwise,
Otherwise, I have to use that only.
okay.
Sir,
Okay.
we can double click on that
Yeah,
box.
these are
We'll
not the
move
things of
to
FDP to be
PLP.
covered. Please move on
Yes.
that thing. I'm not teaching you computers here. So,
Sorry,
and no donation.
participant,
Yeah.
participant, please refrain yourself from asking the questions in between. Otherwise, the session will not be able to cover
Yes.
whatever it should be covered. After
Yes,
that,
yes.
15 minutes, we will have question answer session. In that time, you can ask. Thank you.
In fact, I can have an extended session, maybe, half an hour extended session tomorrow, because we'll have an holiday. Today, we have a meeting scheduled at 12 sharp, 12 with director. So I'll be leaving a bit early. I can excuse there for 5 minutes at max. So that is the point. So I just wanted to cover that. So these are basic things. So I'm not going into that thing. So that way, see, my hand on computer is slightly very different. I try to be as slow as possible while working in these sessions. Otherwise, normally I go very fast in my classes also. So, well, so that way, this is the thing that we are doing. So what I'm telling you that these are the correlations. When you click on the standardized thing, you get correlation. When you click on the unstandardized thing, you get covariance. And these values, that you see on that at the top here, these are the variances numbers which are there. So you see the variances at the top of the individual box here. When you click here on the standardized estimate, you see there's one important value here, which is 0.40. This is something that I want to make you understand. This is very important value, and which you will see here in the table also, which is called squared multiple correlation at the bottom here. So squared correlation, multiple correlation, that is what we call coefficient of determination. Yes, we can generate regression equation based on the estimates, Janvi, we can estimate the regression equation that we can do. So here the value is coming 0.404. If you click here, it will tell you what it does tell you. So in general, the coefficient of determination is a very important number in multiple regression or any regression that we apply. So if I say 0.404 is my R square, that tells you that 40% of the explanation of the changes that are happening in the dependent variable are actually explained by selected set of independent variable. So there is a 40% explanation that I'm actually achieving with the selected set of independent variable here. There's still 60% which is not being covered and captured by this particular regression model. So that is one thing that we should understand. Another thing that we will do, which I'll be probably now completing tomorrow, but I'll just show you. We can see the model fitness here. There's no fun reading model fitness here because here the degree of freedom is 0 because we have only one set of relationship. So this is not a super identified model. So we'll not be conducting any model fitness analysis here because we have only one set of relationship leading to another. So there's no fun reading model fitness indices here. If you want to see those numbers, let us quickly change this model. Let me draw one more, variable here. I'll show you how we can do that. So I'll just quickly go on duplicate thing here and I'll just duplicate this box here. So I'll just do that and I'll add one other term to this also. So obviously I need to assign some name here. So I'll just quickly click here and I'll type in the text, I'll type E2. So small E2 will do that. There's no fun talking about achievement to achievement. So I'll just change the variable here. So let me say the anxiety comes at the place of an achievement. So all these things lead to an anxiety and then an anxiety leads to achievement. That's what I'm making a model with. So this is how we can make a model and the model is changed now. Why I'm doing this? Because now I can see the model fitness indices also. Though I'll be explaining that fitness part in the tomorrow's session. So I'll just recollect. I have changed my model, data set is same. I'll just click on the estimates calculation. Again, the analysis will change. I can click on the numbers here. I can see that number, how that number plays now. And I can go on the text output here and I can see the model fitness indices now. So now I see the values of NFI, RFI, IFI, TLI, CFI, all these I values. And a quick remembrance, if you want to remember, though I'll share the fitness indices summary and the interpretation and what should be the ideal benchmark values by day and today. These values should be more than 0.9. So if your model fitness indices are coming above 0.9, wherever you see that I, CFI, TLI, whatever you see, these values normally should be more than 0.9. The chi-square value should be more than 0.05. You want it to be non-significant. And then RMCEA value should be less than 0.08. That way it is considered to be a good model. Don't worry, I'll share all this by the day and tomorrow we'll discuss in the model fitness part. So that way, model fitness can be seen only when your model is, in some this shape. So only when we were covering in the first part of the things, we were not seeing any such numbers. There was no model fitness part thing. Now we have super identified model. We have layers in the relationships. Now we can do that.
Anxiety and achievement, sir.
Pardon that?
That we can check the fitness of the model when it is only a mediating or moderating variable in our model, right?
A series of relationships. I'll say that.
Yes, sir.
A series of relationship. We are not talking about mediation analysis right now. There's a series of relationship. The three variables are leading to one and then one is leading to another. There's a series of relationship and that is where the model fitness counts more.
This anxiety variable is a mediating.
It is a mediating variable, but right now my analysis is not measuring any mediating effect. Abha, I'll definitely share that, Abha ma'am, I'll share that conceptual textbook you are asking. I have certain very good textbooks. So I'll drop my email IDs at the end of the session. You can ping me a message there. I'll definitely share. Otherwise, I'll share on the group with the help of ma'am. So we can we have done this now. If we want to do further, let me just complicate this model even further. If I say that, okay, this performance goal directly leads to, achievement, and this interest also directly leads to achievement, they have direct impact also. So now suddenly this, diagram looks more complicated, and you can add more variables like that. And if you just click here, again, you run the, estimates, and you'll see the change output over there. And then you will find this, you can see the output file, and this will be there. So you can go on the estimates and you can see how the models are shipping now. So these are the things. Some basic understanding, obviously, of reading these numbers should be there. But more probably, if you are comfortable with this regression weight, that will help you. That, okay, these values, let's see, I'm explaining you this. Performance goal directly to an anxiety has nothing significant because this p-value is more than 0.05. Similarly, interest directly does not lead to an anxiety. An anxiety is not depending on interest here because the p-value is again more than 0.05. Again, similarly, an anxiety does not lead to, achievement because the p-value is more than 0.05. Obviously, I was just randomly dragging something to somewhere. This was bound to happen. So this disaster has happened. So I'll excuse myself for that. So there must be a proper theoretical justification for doing any kind of relationship building. This is not the ideal way which we were doing. My idea is here to just to show you how can we plot things and how can we generate output and how can we read that output. That's what we are aiming here. So this is the basic part that we do in the path analysis kind of thing. I will just quickly ask you to do one more thing. You can save this if you have done. You can save it somewhere so that you can refer it to that way. Let us just quickly open a new file here and let us see how can we do the confirmatory factor analysis kind of thing. We have done it. We have done the basic part here. Now we'll be able to do it quickly. So let us go to the data file. Click on the file name and then reach to the folder where you have saved the file. And this is the file that we have shared today. I guess you must have received it. So it is confirmatory factor analysis. Just click here and click OK. And once you click here, these are the factors which are there in the models. So these are the factors which are there in the model. So we have a list of variables which are there in the model. So anger and anxiety again, and some depression kind of things are there. So health and anxiety and affability and something like that. So let's say these are the things which we have there. Let us assume that what we are seeing is, that is what we want to do confirmatory factor analysis with. So I'll be selecting only 3 construct right now. We have limited time left, so I'll be just restricting myself to 3 construct. Ideally, you should be doing this to the entire set of the variables that you have in your thing. Now let us understand one thing. In the beginning itself, I explained you that anger 1 to 6, these are the things that that are measuring that how quickly you get angry. And anxiety 1 to 7, are the questions that we have asked for measuring the anxiety levels of a person. And depression 1 to 6, we have asked people, that are they going in depression or something like that. So let us assume that here we want to see whether these, questions that we are asking are measuring the, related construct or not. So that is what we are trying to confirm. We have already identified questions. We already have that questions with us. So this is where we want to confirm it. So sometime, what people do, they conduct, first of all, EFA. They club the variables into the groups, and then they rerun the confirmatory factor analysis. Obviously, that will give them correct answer. Ideally, EFA should be done at a smaller level, then you confirm it at a larger level. That makes sense. On the same data set, there's no fun doing that. So when you are adopting a questionnaire from somewhere, then this confirmatory factor analysis is something that you must perform while, before doing any path analysis or multiple regression or structure equation modeling. So if you are, this is the first step actually, before doing any analysis further, you must refrain yourself to the confirmatory factor analysis just to show that your factors that you have identified and the questions that you are asking to measure those factors are well aligned. So let us quickly do that. We'll be using this option now. So let me just click here, and this is how many options we see in the first set, 6. So I'll be just clicking 6 times here. So this is the 6 questions that I see. Yeah, if you're adopting a scale, then EFA does not make much sense because already, the scale has been identified and adopted. So that is there. So we have taken 6 for this, and let me just create another set here. That is, we have 7 for anxiety. So I'm just clicking 7 times here. And then we have 6 for depression. So I'm just clicking somewhere and clicking 6 times here. This saves your time multiple times. If you would have drawn this individually, most of the YouTube channels, they start drawing one by one. That takes a lot of time. So let us use the shortcut which is available. So if you click here and now click on the rotate part,
Sir,
I'll just,
sir,
yes,
can you please repeat once again, sir? Because it is not selecting if we are clicking on that graph.
okay. Let's say I've taken a new file here, and I'll just quickly, I just take the first of all the data into the file. So that data comes here. This is the confirmatory factor analysis. This data comes in the sheet now. I click here. I click on the third option here. Click once, and this is activated now. You come to your drawing area. Click here. You have to get 6 observed variables. So keep clicking 6 times. And this allows you to perform for the first factor. Second factor and anxiety has 7. So I'll just click on discipline factor 7 times, and then we have 6 question in the depression. So I'll just click on the 6 times here. So now you can click on this rotate variable up part here. So this will rotate the variable like this, which makes data look slightly better. Now what happens, one important tool that I didn't know in the beginning while using the AMos is the preserving the symmetries here. So if I want to move, I've deliberately overlapped them. If I want to use the struck option here, and if I just move here, so this will move this way and this will distort the entire diagram. So what I should do, I Control Z I did, and there's an option of this one, just a bit, this one. Below the save option, the preserve symmetries option is there. You click here and then you move. So what it does, it moves the entire thing here. So even if you want to now, let's say if you want to resize something, so if you want to change the size of this box here, so you can resize that thing. So if you want to change the size of that box, you click here and you just do it, and this will help you to get things in a better way. So you can just move this slightly like this, and this way it will help you to preserve symmetries of the data, right? So this is how you can do. And what we will do in the confirmatory factor analysis, we'll just quickly draw these numbers, these variables into the individual boxes here. So that's what we need to do individually. You might be wondering why we are getting such a lengthy name here. So just quickly click here, and variable label that has been assigned in the SPSS file is visible here, so that you can close and then it will be done. So this is now, I'll be explaining you tomorrow because now the time is slightly over. You might be wondering that we are not able to see the numbers and other things. So we can format the diagram and make it visible, but we'll cover that part tomorrow. What we are doing right now, I'm just quickly just dragging all these. Yes, Monica ji, please ask. You're saying something.
So how to print this model or how to add this model in MS Word?
How to?
Print.
I'm not getting you. There's a lot of background noise there.
Sir, how to print this model and how to add this model जो आपने create किया है उसको हम MS Word में कैसे show कर सकते हैं?
That we will simply, will either take the screenshot of this. We can import this as an image later. That will be telling you later. So you can just take the screenshot, and text output you can always copy paste. And the model that you're creating, you can take a screenshot of that thing and submit it in your thing. So there's an option to that. Right. So this is how I've just quickly, dragged all the variables into the individual thing. So this is how we normally do. I'll just tell you how to make it look better tomorrow, probably on the same data set I'll show you. So Then we'll move on to the mediation and moderation and model fitness kind of things. This is how it does. Now, these latent variables are to be named. So the first latent variable, that name is anger. Let's say we are assigning that name to be anger. So that is anger. You need not to close it. You just keep it here. This circle is again, the second thing is, let's say that is an anxiety. So we go with the anxiety, and the third variable is here, this third variable, let us name it as depression, whatever that is. So what I'll do, I'll take some data set of commercial part as well, so that all of you will be able to connect that how can we use it in a commerce kind of thing. So that we are done with. Now what we need to do, we need to draw the covariances here. So I'll select one by one. So I'll select anger, I'll select this, and then I'll select this. So I've selected three, things here. Go to plugin. In plugin, you find this option of draw covariances. So it will draw the covariances automatically among these three variables. So what we do in the confirmatory factor analysis, we normally just draw all the input variables to that particular factor. Then we correlate all the factors. That's what we normally do. There's no direction. Understand? There's no single-headed arrow from one variable to other. In path analysis, we were doing single-headed arrows moving from one variable, one latent variable or one observed variable to other. But in the confirmatory factor analysis, we just make three measurement models we have drawn. These are measurement models measuring one particular variable, second particular variable, third particular variable, and all these latent variables are co-varied now with the help of covariances. And then we'll run the model. So we'll run the model and we'll see whether these values are aligning with the things or not. So explanation of this output I'll tell you tomorrow. But this is how we proceed for the confirmatory factor analysis. Going to plugins, Nandini, I just, what I did, I had selected three, latent variables. I just clicked here and I just clicked on the draw covariances. So it automatically, draw all the covariances here. So that is the advantage of dealing with plugins. They do that work automatically to you. One more thing that we could do, there are a lot of error variables which I have not named. So what I could do, name unobserved variables, and it will automatically name all the unobserved variables. So this is the advantage of using these shortcuts here. So these plugins are very helpful. At times they give you a lot of small things, and I'll be telling you some added on plugins at the last day, fourth day of this FDP of the, this analysis part. So I have to leave today. I'm really sorry, but the questions I'll be taking tomorrow because I've got 2 calls from the director office. I need to be there. I'll take at least 2-3 minutes to reach there.
Sir, can you please send any research paper as well for some kind of models for references? Thank you. Thank you, sir.
Research papers and some reference text material I'll share to Aarti ma'am and she'll share to you.
Thank you, sir.
Thank you. Yeah, my email ID, I'll drop my email ID for everyone to connect with me, but only for research kind of things. My email ID is in the chat box, so you can use that email ID.
Hello, sir.
Yes,
request हमारे. Hello.
Yes, sir.
Sir, can you share the recording for every day? So probably
that coordinators will do that.
Yes,
sir, we will be sharing the YouTube links in our group, sir.
Yeah, if day by day you're sharing the content.
Yes, we are sharing another 5 to 10 minutes.
Thank you.
Thank you so much, and we'll be connecting tomorrow.
Yes, sir. Thank you, sir, for enlightening us with your wonderful knowledge on it. Thank you so much. The essence of all beautiful art, all art, great art is gratitude. Now I request Dr. Rasamal CS to propose the vote of thanks.
Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. Respected speaker of the day, dear participants from various colleges across the globe, and faculty members, I deem it's a great honor and privilege to propose vote of thanks on this occasion. Good afternoon to one and all present on that. I, on behalf of organizing committee, would like to express our gratitude to the resource person, Dr. Ankit Saxena, GLA University, Madura, UP, who despite giving his busy schedule, he find time to share his experiences and ideas on today's section. Thank you very much, sir. Adding rich value to our institution is the unified support of all the wonderful teachers. We thank the entire teaching fraternity of the Department of Commerce for their active involvement in the engagement. I also extend our gratitude to all the delegates from various institutions across the nation and globe for their active participation virtually. I thank all the faculty coordinators of this FDP for their untired support and meticulous planning and execution to make this day a very knowledgeable day. Thank you all faculty coordinators. Once again, thank one and all present here. I remind.
Thank you, sir. By this, we came to the end of second day of FDP. Once again, thank you so much. Have a wonderful day. We look forward to tomorrow's session and hope you all have a great evening. Thank you so much.
Ma'am, one request, when we will get the recording so we can revise it before the next class.
Today I will be sharing by evening YouTube links. They are both the days FDP will be recorded.
Thank you.
Thank you very much.